I want to thank our two sponsors for the Learning Point. The Learning Point is our training space physically here, but it's also sort of our training program, if you will. It is really about education and sharing and working with the production community, if you will. So it's a space here at our facility, and we have the space in our LA facility as well. But it's really about a jumping off point, a starting point. It includes our blog and our other forms of outreach, seminars that we do, our Twitter feed, if you will, everything that we do to try and communicate with the production community at large. And helping us with that, we have two sponsors who are just generally helping us to be able to deliver information to you and also to keep that communication going. That is Zeiss and Nyla. And so I do want to thank them both for being our general sponsors for the Learning Point. In addition to that, we have our sponsors today for this particular event, the AbelCine Expo Innovation in Lighting. We have ARRI, Hive Lighting, Light Panels, Lowell, Nyla again, PRG, their True Color division, and Xylite, all of whom are here today showing their products. They're going to be up later today presenting and talking about what they have to offer for the innovations in lighting. So as we get to, once we got our little introductions off, by the way, I'm Mitch Gross, the application specialist here at AbelCine. We have other AbelCine employees here today to help you out with any information that you'd like to know and discuss whatever it is that you wish to discuss. We really want to be open to you as part of this community. And our first seminar of the day is Beyond the Bulb, New Lighting Technology. And I think it's important that I start with Beyond the Bulb, New Lighting Technology, because people said, well, what is innovations in lighting? David Mullen, who's going to be speaking later, a very accomplished cinematographer, when I told him, I invited him to participate, and I told him that, we're planning on calling this Innovations in Lighting, he went, wow, he immediately responded, that kind of throws me, because lighting is the oldest thing in the universe. And, you know, let there be light, I guess, but there are a lot of changes going on in the world that we work in for what is the technology that we use to light movies and do our work. So while light itself has not changed, perhaps the way we use it has. And I'm going to go in first of what are the different types of sources of light? Where do you get light from? You know, and the one that we're probably the most familiar with is incandescence. And that's where light is actually sort of incidental. Actually, most things that we get light from did not start out, light is a side effect, if you will. It's not quite an afterthought, but it's something that is incidental to the main activity that is going on. And so incandescence is glowing from heat, where you are burning something, you are charging something to the point where it gets just so freaking hot that it starts to let off light. It glows. And that is your traditional tungsten light bulb, little tungsten filament strip, and it will burn very brightly. It burns really hot, and that makes it glow very brightly. You have a flame, you have the sun, you have other things that are really just glowing in that way from heat. It also means that the efficiency is incredibly low because, frankly, what's going on mostly is it's heat. And, oh yeah, by the way, you have some light coming out. Fluorescence is a radiation form. It's a radiative emission, if you will. And that is where you have a chemical or a substance and it gets stimulated by light waves or energy waves, if you will, electrical power, and that makes that chemical or that substance all charged up, and it begins to just glow. It fluoresces, is the term for it. And that is traditionally like fluorescent lights, if you will, or you can have fluorescent paint. When light hits it or energy hits it, it glows on its own, and it becomes its own source of light. Then you have electroluminescence. Getting into the more technical kind of odd terms, electrons discharging photons. And on its purest state, if going back to sort of high school chemistry and physics, and if you will, you have the little nucleus, and you have protons, and you have electrons and stuff, and making a cell and making a little atom. And when the electrical status changes, your electrons that are spinning around the center of the atom, they change levels, that they move because they're getting stimulated to move faster and such. And when the electron goes from one level to another, it spits out energy, and that is in the form of photons. And so it spits out light, photons. And so that's just how it discharges some of its energy. You have discharge, which is another discharge, if you will, and that is ionized gas glowing. And that is when you electrically stimulate, or however you stimulate something so that you actually change its form of matter. Nuclear bombs put off a lot of light. They do a lot of other stuff, but one of the things they're doing is they are changing form of matter from one status to another, and when they do that, they spit out a lot of light. So I said earlier that incandescence, the sun the sun is a big nuclear bomb, if you will, that's constantly flowing and going. It is changing its status within, and it is actually discharging a lot of light, and that's how we exist, because the sun shines that light on us. And that is happening because of a form of discharge, where you are changing matter, Einstein, matter and energy, and changing the status and such. It's important to think about these different forms of energy, because really, for the first, 60 years or so of photography and cinema, we really pretty much just used the first one, mostly used incandescence. And even up to probably just a few years ago, we primarily still just used incandescence. But it eats a lot of power and puts out a lot of heat. And going forward in life, I mean, I'm illuminated right now by incandescent light, but it's very inefficient. You end up wasting most of your power towards expelling heat, and you get some light along with it. And that is just not good for energy usage to the world. It also means that you're spitting out a lot of heat, which means you have to be pumping the air conditioning like we are in this room right now. And that draws even more electrical drain. And moving forward in the future, what's going to happen is that whether it's government mandated or just the guy paying the electric bills mandates it, or you will rent the use of a studio location and they'll have one fee if you use one type of power, and another fee if you use a different type of power, because that costs them a lot more money. These are going to be things that in some way or another, it's going to affect us. I had a client come to me and said, I need to get away from these hot lights. My clients look at me funny just because I'm using hot lights, and I can't do that anymore. So I have to change. However I feel about it, visually, I just can't be showing up on set with that anymore. Okay, well, that's one reason to change. So it's something there where I always like to sort of step back and from high on the mountain say, all right, well, technically, what is the visual attributes and the technical attributes that? But a lot of this is business. Look, we work in show business, and if it costs more to use something, or I can't amount of time to use something, or I can't travel with it, or whatever that might be, that's going to affect the work that we do. And we are artists, but we are craftspeople. We are working in a business. We have to make things do things that are sound business decisions and sound decisions in the environment and the universe that we live in. That said, we do have other forms of technology that are available to us. And the first thing that does is really scare people because they equate the emitter, the thing that puts out light, with the light fixture itself. And it's just not true, or at least it's not true anymore. So look at all these different forms of light fixtures. All of these light fixtures, and you have different lens lights, you have different non-lensed lights, all these different types of fixtures. I'm picturing here with tungsten in them, but they're all available in different forms out in our showroom right now with other technologies in them. Technologies that perhaps don't put out as much heat, that certainly don't draw as much power, that have other parts of the color spectrum available. All are available with all these different types of technology. So these fixtures and the emitters within separate that in your mind. Let's think now about different types of emitters that can go into the traditional lighting control devices that you are used to using. And so you can still, one, you can still do the work that you're used to doing, but two, it can actually start opening you up to the options and the possibilities of what you can do. And I got a lot of people who are just sort of afraid of change. They don't like the idea of like, well, I've always done it this way and this has worked for me and I don't want to have to deal with something new. But if you open yourself up for the possibility, all right, I can still do that work that I'm used to doing. I can still use the type of instrument that I'm used to using. But now I have something that goes inside it that's a little bit different, and that frees me somehow. And that's going to be dependent on what work you're doing and, and where you see yourself going. You have these options available to you. So let's look at the different types of emitters and their attributes, the things that you want to pay attention to in what different emitters are like. And the first thing is color. That big triangular kind of hump thing is known as the CIE 1931, right? 31, yes. Back in 1931, the year that the whole scientific study done, and they figured out what the actual visible spectrum meaning our eyes, not a dog's eyes or whatever. It's what we can see in the world, what we are capable of perceiving. And this is a two-dimensional representation of what what is actually a three-dimensional space and such. And I've seen other versions that represent in different ways. And the triangles that you see within are different electronic or other physical printed color spaces, meaning when someone says, what's the color space of this format or whatever, that's what they're referring to, like Rec 709 or Pantone printing colors or projection, film print projection, stuff like that. They all represent a window within that bigger triangle of what is visible light, what we can all actually see. So that's what's represented there. And then you say, well, my lights, what are they capable of? What can they put out? And that's where you have a black body source. A black body source means that, and I never quite understood why they call it a black body source as opposed to a white body source, but a black body source means that that source of light puts out all colors of the rainbow, as it were. It puts out all forms of, all visible light. It might not be as much on one as on the other because it might be weighed a little towards the blue and then it's a kind of a bluish light, or it might be weighed a little towards the red and then it's kind of a reddish light. But then that light it is technically, physically capable of outputting all colors. And so that is a black body source. It just has all colors of the rainbow in it. And that's important because certain technologies along the way just couldn't always do that. And sometimes you can't get a really good representation of it. That they're referred to as non-continuous sources. So if you imagine that instead of the CIE chart, if you look at the smaller chart there where you just have a prism separating things into the rainbow, the different colors, imagine that as just a big line, and that's your visible spectrum, blue on one end, greenish kind of in the middle, and then red on the other. If you have a non-continuous source, it either has little dropouts along the way, or it has some oddball little spikes sometimes, often in the green part of the range. It has little spikes of light where it's just, whatever the chemical composition or whatever it is that's going on in that thing that makes light, however that is happening, it has deficiencies in that it just doesn't produce that particular color, or it overproduces other colors, kind of thing. And it's often these narrow little spikes or trowels that, okay, that's not a continuous light source. And that's something we always worry about, because if it can't show that color, it can't show that color, and I can't, bring that back. I have to worry about that. But this is not to put fear in your minds. It's really to say, like, all right, well, what is it that I'm looking at, and then start looking at lights and seeing what they do. You start looking at color, measuring it by something called Kelvin and CRI. Kelvin is it's the Celsius temperature scale. It's just skewed a different range, and that is just the color temperature of your light. And that is essentially, if you're looking at that graph at the bottom, the chart at the bottom with the prism spread, that is the range from red to blue. Imagine color as a seesaw, and you have red on one side, blue on the other, and green's in the middle, and that's the pivot point, if you will. And when you're adjusting color balance, you're adjusting the level of red and blue to one another so that you are shifting how warm you are to how cold you are. There's actually a little line that's going across in a slight hump in the middle of the CIE chart there, and that is representing different color temperatures. You see, it's actually a very narrow little path along the middle of what is CIE 1931, the middle of what is all visible light. But that's charting between between red and blue. And then you have another bar, another measurement, if you will, which is your green magenta shift. So you have your red and blue balance, and then you have green magenta. There is no such color in reality as magenta. Magenta is the absence of green. It is a lack of green. Just like there's hot and cold are not opposites. Cold is the absence of heat. Light and dark are not opposites. Darkness is the absence of light. Well, magenta is not the opposite of green, is the absence of green. Wrap your brains around that for a sec. But the idea is that if you had that seesaw of red and blue, then in the middle you have a push up or push down of green. How saturated your green. Now, I mean, obviously there's a lot more deviation, what shade of green, and stuff. There's a lot of deviation within there, but on the most basic level, that you have your balance of red and blue, and then you have your green magenta strength of green, if you will. And that is how you tune color. And so it's on a given light source, how tuned is that light source. So CRI is a color rendition index, and it's, you can take that color spectrum. CRI is often, it's published as a number, and it can just say, well, this light has a CRI of 92. And what the hell does that mean? How close is it to a black body source? How close is it to something that has a really good color rendition of all across the spectrum? The problem is that you're averaging a bunch of numbers along the way, like, well, how good is 92? There are some manufacturers who divide up the color spectrum into like a dozen or more little windows, and then they give a measurement of how accurate it is in each of them. And then, and so if you can get that information, it's like, all right, well, I know how well it tracks throughout the color spectrum, because, what if it was 99 on all of them except for one section that was, 70? Well, guess what? That's going to be a really ugly light. It's going to have this one area where it totally is wrong and the weird colors, and it just looks terrible when you actually put that together, because suddenly it might be really, really green in this one part or something, or really not green. If you have a bunch of numbers along the way, and then they all kind of average out nicely, and then you have a number, and that grand total is CRI, and it's a good general indication. If you've got a light that's a 75 CRI, don't bother. If you've got a light that's a 90 CRI, all right, now we're starting to get somewhere. This could look pretty good. It's a scale of just getting a general sense, and then you start having to really analyze these lights to look at what they're actually doing. That's why we have them here today, why we have the manufacturers here today. Yeah, you had a question?
Does CRI go up to like 100?
CRI, in theory, what's the scale? In theory, a CRI scale goes to, an absolute perfect light is 100. You're absolutely measuring everything even to 100%. I got to tell you, even tungsten lights do not have a CRI of 100. They're like, I don't know, 98 or something like that. There's certain points where it just doesn't represent every color that our eyes are capable of capturing and processing. But, they get up there. So yeah, the scale is, to 100. And any light that's, once you get into the 90s, you're starting to look at pretty good lights as a general indicator, unless, it was 99 all the way until it had one that was, not so great, and they averaged and it looked like it was good, but, So, anyway, the next one is control, because we need to be able to actually use our light fixtures, and they have to be able to function. And when different technology lights first entered into our industry, suddenly we were faced with lights that we couldn't control our lighting the way that we were used to. The first thing being hard versus soft. It's great if you have a hard source of light that you can then choose to soften in various ways. If you have a light that is, if all you ever want is a soft light, then you're wasting the efficiency of a hard light by starting off hard and then having to knock it down and soften it. So maybe it might be nice to have a light that is naturally soft. So think about like fluorescent lights. They are always naturally soft. If you want to get hard light out of that, that's the wrong tool. But you have different devices that can deliver light to you in different shapes, if you will. Then you have the lifespan of a light. Let me tell you, tungsten lights, and various different technologies can have, count them in, I had old photo floods still in my closet. They would have a lifespan of 27 hours or some ridiculously low number. Now there are some lights that we're going to be showing you today that have theoretical lifespans in, in the tens of thousands of hours. Longer than you're going to choose to ever use this light fixture. This will just keep going. And that means you don't have to think about it, you don't have to worry about it, and you don't have to pay to keep replacing bulbs in it. Or if you rig it somewhere, you don't have to ever worry about having to climb back up there to get to the thing to change the bulb in it. It just, that's an issue that's removed. Strike time. Some lights take a little bit of time to come up to their color. And some lights are instantly turned on and they're just ready to go. Some lights they have a cycling over time. They start to lose their color performance or their brightness performance, and they shift over time. These are just things to be looking out for in different technologies of lighting. Heat output. Again, tungsten lights put out something like 85% of their energy purely in heat. So it is, and every light that we show you here today will put out some of its energy in heat, because heat actually is infrared. It's actually a form of the same radiative energy that is light. It is just a different part of the spectrum. It's non-visible light, if you will, but it's still the same stuff. So how much heat does this unit put out for relative to how much visible light does it put out? And the balance shifts dramatically with some of these different fixtures. And then dimming capability. And dimming, some lights will just not let you dim. Some lights will dim no problem all the way throughout their range and won't change their performance in any way other than their brightness. And some lights will dramatically change as they dim. They will alter what you get out of that light as you dim it. It might change its color, or it might do other things, which we'll get into. Then flicker. And this is something that I care about a lot because we do a lot of high-speed work, but more and more there's cameras coming out with various frame rates and various capabilities. The Hobbit just came out, 48 frames and stuff. I don't know we'll see how well that does, but there are different ways that lights pulse and run. A match and the sun are just on. They just they're just on and that's it. But other light fixtures aren't, that ain't so true. I can take a tungsten light, and if it's on battery, DC power, then it is just on. But for the most part, we run on alternating current. And alternating current means that you are cycling power in a sine wave up and down, on and off, on and off. And if you have a really, really, really bright tungsten bulb, then a really strong one, then it gets just so crazy hot that it doesn't have a chance to dim in that cycle. But otherwise, it might flicker if you shoot at off-speed frame rates with your cameras. You have LEDs and other technologies that use something called pulse width modulation. Basically, when they turn on, they only turn on at a certain strength, period. But the way that they control the brightness is that they're pulsing them super, 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 super fast, and reduce the number of pulses, and that means it's less bright. And so that's what a lot of LED technology uses, pulse width modulation, to decide how bright you are as you adjust that. There are other forms of modulating brightness, so that some of the fixtures we have here today, you can adjust the brightness on, and yet they don't actually ever flicker. You have something called decay, where a light will be on. That's what I was sort of referring to. With a tungsten light, it would be full bright, and then it gets dim, and it gets full bright, and bright, dark, dim, bright, dark, as the power cycles up and down. And your power might be dropping into steady speed, but the brightness, as it loses its energy, might take a little bit of different cycling time, and so you can't necessarily balance one to the other and such. These are all things that I just mentioned because they're things that you have to pay attention to if it's the kind of work that you're going to be doing. So you can see with some of these crazy lines and graphs and stuff that all those things can start interfering with each other, and that's when you suddenly get flicker, where the rate of it. Be thankful, by the way, that I chose not to use the epileptic seizure designed video clips so I was like, where can I show flicker? And I was like, oh my God, you can really have really ridiculous things that can come up, and you don't want to see that unless you really want to plan to. And then dimming again, you have different ways that you can control dimming in your light, and it can affect whether you get flicker in the image. Power. Now, and again, I'm going to breeze through a lot of this stuff, if only because we have all the manufacturers going to come in, and they're going to each talk about their products and their approaches to different ways of creating light, so that, and I want to give them fair time to be able to tell you about what these pretty neat technologies. But I just want to point out real quick. Here's different. Don't go by these numbers. This is a chart that I found that is talking about a lot of industrial lighting and such. So it's not necessarily accurate to what we'd use in our world of production. But here's different types of lighting technology: tungsten, HMI, fluorescent, LED, remote phosphor, and plasma. And we'll get into all of these. And you can see, as you look at this chart, the least efficient for amount of light that you get, lumens, for how much energy, wattage, that you're using. The least efficient is a little tungsten light bulb all the way on the incandescent light on the end. You get very little light for the amount of power that you put into it. And then as you move into other types of technologies, you can vastly increase the efficiency. So you get way more light relative to how much power you're using to output that light. And so this starts freeing you for when you're going on a practical location, or you have to work off battery power, or you are in a physical space that just will only allow you to use a certain kind of power. I need to be able to get my shot. I need to be able to do the work that I need to do. How much, if I use certain kinds of lighting instruments, I'm just only going to get so much light because I can only have so much power available to me. So real quickly, I'm just going to go over the different types of emitters. You have tungsten lights. They are very inefficient as far as power. They are pretty much available in a very warm color temperature. That's 30 3,200 degrees for quartz lighting, which is a little whiter, if you will. That's what's lighting me right here, as opposed to tungsten, true tungsten bulb, which is just a little filament strip, which is sort of what you have in household lights, as opposed to a quartz light, which redistributes stuff. And anyway, halogen effect. You lose 80%, and actually, depending on the type of fixture, it's even more, 80% of energy gone as heat, tossed away as heat. So you're getting only a small percentage of it is going towards actually creating light. And it is a black body source. You also only get, you know, in the hundreds of hours for lifespan of this bulb before it's gone and time to replace the bulb. HMI lighting, which is HMI, hydrogear medium arc, always tongue ties me. It's a mercury vapor with a metal halide, and the halide is a metallic material and stuff. It's floating in a gas form, and when you basically you have electrodes on either side, and you put an electrical arc between them, and that gas gets excited, and then boom, it glows and it lights up. Wow, going from like 30 lumens per watt up to 85 to more than 100 lumens per watt. Big increase in brightness. Also, this is daylight balanced, if you will, natural sun daylight. It does require a power supply of some, basically an electrical transformer, just so you can have the frequency of power to get enough spark for that arc to form inside the bulb, and that's then gets everything light up. You have issues of something called flicker, which we just spoke about, but something else called arc wander. Again, this is only if you're doing high-speed photography. It used to be an issue with very old HMIs. Now all modern HMIs don't have that problem, except when you're in high-speed photography. Basically, inside that bulb, you have your two electrodes, and it creates an electrical arc between them, and it's going back and forth, the direction of power, constantly. And as those electrodes sort of burn down over time, that arc is changing its speed, or it kind of wants to, it works a little bit better on this side than on this side. So when it's going this way, it goes fast. When it goes this way, it's a little bit slower kind of thing. And you end up with the cloud of glow of gas that's inside the bulb is sort of shimmering, kind of moving back and forth. And you don't see it at all with the naked eye, but when you shoot really high-speed photography, then you can suddenly start seeing this weird shimmer effect going on inside it. People do it every day, and they get away with it. It's something to be aware of. And that's something that HMI lights can do, so that you might have flicker, you might have arc wander, separate things, coming out of your light if you try to shoot in high speeds. And that's anything over 120 frames a second is what we would consider high speed, at least in the US, because we're 60 hertz power, so that's 120. In other parts of the world where they have 50 hertz power, then it would be at 100 cycles a second, or frames a second. Relatively short bulb life, again, in maybe the hundreds of hours before the bulbs start to decay enough that it's time that you have to change that. In fact, a lot of these HMI lights have a little meter on the side telling you how many hours you have. And you can actually run the light for longer, but suddenly, I run the light and I look at it and like, it's pretty ugly. I'm like, I need a new bulb in that light, because they've been trying to get a few extra miles out of that thing. And it is a slow strike, meaning that when I turn on that light, it's going to take a minute or two to get itself, all that gas inside that bulb has to get itself up into its chemical reaction and get glowing so that it's the right color and brightness and such. That's how HMIs work. And you can stick those into different types of fixtures like we were looking at before, but it is that type of emitter. And you have fluorescent. Again, I'm going to kind of fly through this stuff because I want to get to what is new stuff. You get pretty good efficiency out of it, anywhere from 50 to 100 lumens per watt. That is depending on what color it is and also how good that color is. So I can get a really bright fluorescent light, but I would not want to light my basement storage closet with it. I mean, it's really ugly. It'll be really green. It'll just not, it'll make you look sick if you're in that light. If I get better, it's a glass tube with phosphorescent material in a powder form, sort of coating the inside of the glass tube. You have electrodes, and they make electrical stimulation inside, and that makes the phosphor glow, electroluminescent, or fluoresce. And so, depending on how well they could distribute the phosphorescent material, which phosphorescent materials, it might be a better color, but it's not quite as bright, but you'd rather have the right color. So that's why you have the different amounts of lumens per watt. It is a naturally soft source. If you want a soft source, great. If you want a hard source, you're out of luck. So it is useful for certain types of work. They weigh nothing. You can run around with the lights like this, so that's nice convenience. But it only works in certain kind of ways. You can swap out the bulb so that you can go switch between daylight and tungsten or other colors as you go. But you just have to actually pull the bulb and swap it around. Okay, CRI. The HMIs, are either in the 90s, so they're pretty good CRI, at least when the bulb is young. Here, different manufacturers, different things you'll hear and stuff, but when you get up there, you're in the 85 to 90 CRI range, and where you really see it is in the green magenta range. You'll see, depending on the manufacturer and what their bulbs look like and stuff, you'll start seeing that shift in like in the skin tones, like, oh, it's like looks a little bit purple, or oh, this one, that it's got a little odd bit of green in it, and it's not like something you can just put a gel on and filter, because you put a gel for that's plus or minus green, and it does like this whole range of green, but in that whole range there might be only one little spike that is too high or too low that is shifting what that color looks like. So you're going and pushing everything around, and it's really the issue. You can't get a gel that's just this narrow little, 430 nanometers of color. It's going to overdo it, and so it's really hard to control that. They are lightweight, easy to run around with, and the bulbs do last quite a long time. You can get, hundreds into the thousands of hours with a fluorescent bulb before you'll most likely break it from running around with it before it'll die. Then you get into LEDs, and LEDs get a really rough rap. Because when they first came out, there was all about, it was on your clock radio, and it was just one color, and very specific. And then they start trying to get natural balance of colors out of them and stuff. And there's different ways. You'll see different manufacturers will either, in certain technologies, they'll have one LED or one group of LEDs that are all the same color, and they'll push out, certain light. Others will use a mix of different color LEDs to together create the color that you want. The technological improvement that's happened in relatively short time with LEDs. LEDs are decades and decades old, but in the relatively short last few years has dramatically improved the color performance. And it's driven by the consumer world. It's driven by LED TVs and LED displays. And I'll give a little shout out to a manufacturer that we don't represent. This is from IKEA. And it's a little 3 watt LED light that I got for my kid's bedroom. And it's kind of amazingly bright for this little light that can really put out a lot. It's actually a nice hard cut, the shadow lines I get from it. And it's $10. And when I saw it, and I was like, well, if I took a whole pile of those and lined them up, I could really make, $300. I could have an interesting, But that's a real science project. But that's why, for every motion picture light that costs whatever dollars, they'll sell one of those, and they'll sell 10,000 of these things, and that's how that drives the industry. That's a 2,700 degree Kelvin, so that's kind of warm. It's a nice little trick light. Have a little something like that in your kit. But for $10, I have a pretty good tungsten balanced light, if you will, that just to get me a little trick kind of a thing. And that technology breeds out to our industry so that we can, refine exactly the ones that we want to use and really get great performance out of some piece of technology. You have various color temperatures that are available, and you'll have various CRI. Some manufacturers, there are some brands you will not see here today that they'll bring it in, we'll look at it and we'll be like, oh my God, I couldn't sell that to someone in good conscience. And then you'll see some of that stuff. Don't go by just written spec alone. It's a light. You want to look at it. You want to see what it does. That's why we're here today, to see these lights. Because boy, it's embarrassing sometimes what some of these things can look like. The way that an LED works, you have a little diode, a little electronic emitter, and it's usually like super blue. That's usually what that color is. And then they have these phosphorescent materials that are just doped on top of it. They're literally just painted right onto the surface of the thing. And when the LED emitter goes through these phosphorescent materials, those materials then glow along with the electronic emitter, and together they produce whatever color light. Well, it's how many angels can dance on a head of a pin. You have this little spot, and this stuff is poured right on top of it. And as much as we think of LEDs as not producing heat, that right on that surface, it's like ridiculously thousands of degrees, super, super, super hot. And you have to have material that will be able to withstand that. And so over many, many hours, thousands of hours, that might start changing color, but at least at first, it's got to be able to maintain its color, and it's got to be able to continuously perform. So we can have 10,000 hours plus of light. Some of these lesser lights, after a relatively short time, might not look so good. You might not want to use them. They might lose their brightness. Others can look really, really nice and, and perform very well over time. So there's a lot of variation between different LED manufacturers and how they arrive at what they do. You have remote phosphor. This is taking LEDs and going a different direction. What if we have that emitter source and we physically separate that phosphorescent material? So unlike in a fluorescent bulb where there's electrical discharge and it's happening inside this tube and the phosphorescent material is right there, or an LED where you have a little emitter and the stuff is doped right on top of it, painted right on. This is a bunch of LEDs. It doesn't have to be LEDs, but in the case of these lights, usually it's an LED light source, and then behind it, pasted in front of it, are the panels. And those panels have phosphorescent material that's actually just painted on. The LEDs charge up the phosphorescent material, and then that becomes your new light source. And so these things just glow. And because it's such a large surface, and you don't have to worry about heat issues, and can this stuff withstand that heat, you can use different stuff and get that color very, very accurate by having a large surface you can paint it with. And then this is not a hard light. This is that whole white surface, that whole front surface is your emitter of light. So it's a very even glow of light. But you then get a very nice color out of it. So it's a very different type of technology. The efficiency is pretty darn good. It's a dimmable device. Because you're using separate little emitters inside there, if they start to change over time, you have this big surface. So over a long time, it will maintain its color very well. It will maintain its brightness because you're not dependent on like one little thing on one little surface and such. That's why you get 20,000 plus hours of life out of the thing. And we have them here. The manufacturers are going to show you these things, but it's pretty interesting sort of offshoot, if you will, of LED lighting. Then you get to remoting the phosphor, so remote phosphor technology. And then the last type of technology is plasma light. And plasma, remember what I talked about before or light emitting plasma? I said changing the physical status of the stuff in the bulb. It is actually going, it's a little glass bulb, and there's no electrodes or anything on it. They put it inside like a microwave chamber, and they bombard it with energy. And when it's bombarded with energy, it changes status from being a gas to a plasma. And when that happens, it discharges all this energy in the form of light. And so you have this brilliant, clear light that is daylight balanced. It's super, super bright. You see 170 lumens per watt, very, very efficient brightness. It has a lot of interesting aspects to it as well. And again, long lifespan. I don't want to cut that one short as much as I know the manufacturer will talk about it when he comes in. So I want to go to the individual manufacturers now and let them show you what their different lighting technologies are about. Our first one is ARRI, and they're going to show you some of their LED lights. So Jane, if you want to come on in with your lights. See where's Jane? She's coming around. She's on her way. I surprised her. She didn't know that we were going to suddenly switch to that. Do you have, we have the microphone? This will just take us a minute. We have 7 different manufacturers, and they're all going to be spending just a few minutes showing you what their lights are. And while I'm waiting for her to come in, I have a question here. CRI of plasmas is very high. It's in the mid-90s. It's pretty much up there with HMIs in efficiency and of color rendition. So it's a very high, very good color that comes out of them. Yes?
Also relating to CRA, I mean, you mentioned not just living with the manufacturer spec, but unlike Tungsten, you know, you don't know where the problems are. You can't actually walk around with a color chart and test and say, oh, your light is a problem. How do you know unless somebody does testing?
Well, the question for our people watching, people who can't hear in the back, and also for people watching on live stream, is how do you know what the CRI is, and what is the color rendition of a light? That is going to be our last session of the day. We're actually going to compare and test different lights, and on a subject here, I'll have a model on our stage, and we're going to look at it. And the best way to know about what a light looks like is to look at it. And we'll be able to see from that, and we'll be able to get a sense then of what the actual rendition of color is from these lights. It's a good question. The thing is that, you know, back when we were shooting on film for everything, and those days, they quickly are dwindling, the only way to know what it looked like is to shoot a test and get it developed and then see the thing. Now we have a sort of instant gratification that we have very high-end electronic camera systems, and we're going to be using Canon C500 as well as an ARRI Alexa to really see what lights look like, what are the outputs. We can judge it not only by what our eyes see, but what the camera picks up. And in the end, you know, we're lighting, you know, at least most of us here are lighting for a camera to see something. So that's what we're going to look at to get a sense of how it appears. Jane, are we hot with this? Okay, so I'm going to turn this over to you. Yes, we are live streaming, so there we go.
So my name is Jane Ryan. I am the Northeast Regional Sales Manager for ARRI. I've been in various parts of the industry for close to 13 years now. I've been with ARRI for about 2. What I have today to show, we have 2 different units. This is our L7C. It's a 7-inch Fresnel LED light. I also have one of our caster series. I'll start with the L7. As most of you, I mean, just a raise of hands, how many people have heard of ARRI in the room? That's the point. You know who ARRI is. We've been in the film industry for over 95 years. We're not going anywhere. When you think of ARRI, almost everyone thinks about reliability. We have great service. There's a reason why you go on any film set, we're going to be there, because we show up, the lights show up. So that's really an important quality of who we are, is we are familiar with the desires and needs of people who light, and what they work with lights. So when we were working to develop our LED, we didn't want to reinvent light. We didn't want to reinvent how you work with light. You guys know what you're doing. The intention was to create an LED and a very efficient system without having to recreate how you work. So what we did, this is a single point light source. It's a Fresnel, but it's a really cool one. This is I'll come over here so we can do it on the screen. So the intensity control goes from 0 to full, and there's no shift in color temperature. One of the things you'll notice about the light beam itself, it's incredibly even and smooth. That was one of the things we're looking for, is just quality of light from the fixture. I have it in 5,600 Kelvin here. The correlated color temperature goes from 2,800 degrees Kelvin up to 10,000 degrees Kelvin, and that's continuous. Pop it back to, this is your plus and minus green. As Mitch was talking about, you do have hue and magenta shifts with LEDs. What this will allow you to do is match any other LED. It helps you match fluorescent lights. Yeah. The L7 has a hue and saturation mode. What that allows you to do is get any party color you're in the mood to play with that day. Suddenly, you don't need gels. So you can literally go through the full color spectrum. If that's, let's go blue. If that's too blue, you can desaturate it as much or as little as you want. In terms of what the light does, as I was saying, we're looking for light, quality of light. This is, you can actually use your barn doors with this LED. And that's one of, we wanted a single point light source. That was the goal. It's a 7-inch Fresnel. In terms of equivalency, it's close. If there was such a thing as an 800, it would be very close to that. We do have the spot and flood. And so depending upon where you are within that determines the intensity of the fixture. You have, there is a fan in here. You can program the fan. The user can program the fan. You can have the fan always be off. The fan can be on. The fan can be on in a low mode or in a high mode. We've actually very rarely have the fan on in the high mode. The one time we had it that, the customer's like, oh, my LEDs are overheating. He was shooting in New Mexico in the desert this summer. So we're like, put your fan on high mode, and it was fine. And that's all programmable through here. We also have 2 DMX ports in here, both in and out. So you can use it, run your fixtures via DMX. So there's no more climbing on the grids. I was doing it on board, DMX. It's also RDM. There's a USB port. The point of the USB port is you can upgrade your light. It's a digital fixture. It's we constantly come out with, as users give us feedback, I want this in the fixture. We have programmers on our staff now, so we can actually program to meet what people want within their light fixture. So you can just plug in your computer and download an upgrade. What else to tell you about it? The other point of upgrading is the LED array is upgradable. So because we know the LEDs are rapidly improving day by day, you can just swap out the LED array. The light engine as well, which is it's basically a little motherboard down here, that's upgradable as well. So, it's not an expendable. It's a light fixture. It's part of your toolkit. To that end, where this is a Fresnel, there are other types of light, and that you want in your toolkit. You're basically building a house. You don't build a house with just a Fresnel. So we do have the Caster series. I have this plugged into the wall right now. Let's turn this one off.
What wattage does that take?
Oh, this is drawing 2 amps. So the Caster series, it's basically a little fill light. You again have your color temperature control from 2,800 Kelvin. This one only goes up to 6,000 Kelvin, but again, it's a continuous control. This has also the plus and minus green built into it. So depending upon where you are, how your camera sensor is responding to the LED lights, you can control that. I'm going to dim this so I don't blind you, and I will. But again, it's a very smooth, it's a very even light source, and that's the point. It is basically a fill light, is what a lot of people are using it for. It can be battery controlled. There's a battery that just slides into the bracket here, so it's AC or DC. It's an airy battery, although if you have a Dionic 90 from Anton Bauer, there's a bracket that you can just adapt it to. And these are, in terms of equivalency, close to about a 125. There's an intensifier that you can slide on here, which is just basically a metal snoot, basically. And that will narrow the beam angle from 66 degrees down to 33, and also double the light output. And this is drawing 35, well, it's variable, but nominally about 35 watts. Questions?
When they overheat, you said that it was overheat. What happens to the LED?
What we've done is we put in a safety switch on, so this indicator light will start glowing red about 5 minutes before it overheats, and then the fixture will turn off because you don't want to damage your fixture. So.
What is the size of the single point?
It's not one single LEDs, it's an array. It's about 88. I'm not sure of that exact number, but it's approximately in the high 80s of different LEDs that are arrayed to make a single point light.
You might want to mention the Fresnel lens is glass, not plastic.
It's not glass, it is plastic.
It is plastic.
It is plastic.
Initially, you guys were going glass.
In the early prototypes, we did have the glass one, you're right. What we were able to do, the optical engineers were able to create a plastic lens that they liked. So, and that gave us about a pound worth of weight savings. So.
How durable is the fixture, like the housing on that?
It's very durable. It's the same plastic that airplanes are made out of. So it's very durable.
And because it has like the motherboard stuff in it, that's pretty secure. It's not like shockproof and stuff.
Yeah, the thing you want to remember is it is a piece of electronic equipment. I personally would not put my iPhone in the bottom of a bin and put light stands on top of it. Treat it, as an electronic piece of equipment, and you won't have any problems.
So how that has higher output?
We will soon. We'll very shortly have a lower power class and an upper power class. They've not announced which direction they're going, but by NAB we'll definitely have more information on that.
I think we're going to go on to the next manufacturer, and anyone has more questions for Ari, we'll be able to go out into the expo floor and be able to do that. Thank you very much, Jane.
Pleasure.
So our next manufacturer, and I'd say that do that not to cut anyone off. I just want to make sure that we get time for all of our manufacturers and everyone will have a chance to see everything. Our next manufacturer is Hive. Hive Lighting has the plasma light fixtures, and so Jamie Emanuele from Hive is making his way in now to be able to show you one of the several fixtures that they have. You can plug in right there, and that way you don't have to worry about stretching your cord. And here you go.
I gotta hold this thing?
You gotta hold that thing, sorry.
I don't have that cool little headpiece thing yet.
You're not Madonna.
I was gonna say, no, I'm not. Let's put this way. Alrighty. Good morning, good evening. How are you? Can you guys hear me? Hello. Hello. Thing on? Yes, it is. My name is Jamie Emanuele from Los Angeles. Hive Lighting, Hive Plasma Lighting. A lot of you may know what plasma is, some of you may not. Basically what we've done is we've created a new segment in lighting. This right here, what's in my hand, is about the size of a Tic Tac, is the bulb. This is what's producing the amount of light that you see. Basically how I like to describe it is that what plasma is, it's the benefits of an LED, but the output of an HMI. So we have a single point light source that draws, the whole system is drawing 270 total system watts of power. If you notice, there's no ballast on the floor. It's a direct replacement for your small HMIs. Very little power consumption, 2.6 amps. They're DMX controllable. Virtually no heat, it's just warm, like a warm cup of coffee. You can actually put your hands on the lens, which you can't do with traditional HMIs. Truly flicker free. Most lights run between 50 and 60 hertz. We run at 450 megahertz. So therefore, for high-speed shooting, phantom shooting, that kind of stuff, you can get up to about 220 million frames a second. We're still waiting for them to be able to get there. We did some tests at 1 million frames a second with the government. Not a problem. As a matter of fact, we were at IBC. And what was amazing was actually Vision Research was there. They didn't believe that our light does what we say it does. So they took this light, and they took it with their new Phantom, and they cranked the Phantom up 25,000 frames, nothing. 50,000 frames, nothing. 100,000 frames, 1/5 millionth of a shutter angle, nothing. Then they actually pointed the phantom directly into the light source, and it's nothing. They said, well, it is true, and you can't have the light back. So they actually took our light, and now it's traveling through Europe with the phantom, and this is the light that they use when they show the phantom. I'm going to the crash test facility here in Virginia. They're using 750,000 watts of tungsten to do the crash test facility for the highway safety. We're going to be looking at transitioning that to about 60,000 watts with the same amount of output with no heat. The other great thing is it's got a 10,000 hour bulb life. The bulbs actually last about 30,000 hours. We only claim 10 because our color temperature, which is 5600, 94 CRI, full spectrum, will be consistent throughout 10,000 hours. So you pretty much never change a bulb for the rest of your life. After the 10,000 hours, it'll shift about 500-600 degrees blue. Still usable, but if you want to, you can change it at that time. Pretty much indestructible. There's really nothing that you can do to hurt these other than the glass lenses, which are, you know, glass, of course. They break. Standard accessories, 6 5/8 doors. Your chimeras will fit it. Run it off of batteries for hours. It usually takes a couple of battery belts in order to run a 400-watt HMI for about 20, 30, 40 minutes. Ours run 18 to 38 volts DC. So anything you give it, it'll run it for hours. It'll take one battery belt and run for 2 hours as opposed to 2 battery belts for 20, 30 minutes. We've got voltage regulation inside, so therefore when your batteries start to deplete, usually your color temperature starts to change, your output starts to change. We have voltage regulation, which keeps the color temperature and the output exactly the same throughout the life of the battery. So it's great for location work. You don't need generators anymore. If you're shooting, we were doing a feature in LA, we were doing the show The Mentalist, one of their shows and a feature on the 27th floor of Lowe's Hollywood, on the top of the hotel, and they called us because they didn't want to run 4-aught 27 floors up to the generator. So they called us, and they ended up doing the whole shoot, the whole feature, did the same thing on a 5th floor, everything in 20 amp outlets, 15 amp outlets. I mean, you can run 5, 6, 7, 8, 9, 10 of these into one plug. Normally when I do this, I'll have like 10 lights, I'll have 2 stingers and 3 cube taps, and I just run everything off of that. So I don't know if there's anything else I can tell you. It's a boatload of light for a little bit of power. Use it anywhere in the world, 85 to 277. We also have, you treat it just like an HMI. So you have your lens set. If you need to dim, you use diffusion. We don't dim. We can dim, but we go really blue. So you use your scrims, but we came up with, because we don't hot restrike, it takes anywhere between 10 seconds and 2 minutes depending on how hot it is outside. We were shooting a BMW commercial in the middle of Joshua Tree, hottest day of the year in LA, and it was 110 degrees. We had our 4 lights out there in the middle, baking in the sun, turned them off, took about 2.5 minutes to come back up. So we have this function called standby, or our low mode. So it reduces the power by 50%, 25% output, and what that gives you, it's about 12,000 Kelvin, a nice blue glow. Gail Tattersall from the show House was using them, and he actually says, you know, Jamie, this is the most beautiful moonlight that I've ever seen. So anytime they shoot at night, they put all of our lights in standby, and they don't have to gel, and it's a really, really, really beautiful light. But the reason why we created it is that when you hit that high button, your output and your color temperature come back up in less than 3 seconds. So you're not having to wait that 10 seconds to 90 seconds that it might take. Any questions?
What about your different fixtures?
Different fixtures, yes. We have 4 different models. This is our WASP Plasma PAR, 270 total system watts of power draw, equivalent to about a 400-watt HMI output. We have a Hornet Plasma Fresnel, which is coming out first quarter this year. The same 270 watts of power consumption, but we gained a little bit more on the Fresnel, so it's actually about a 600-watt Fresnel output, greater than a 575, still drawing 270 watts. We have a 2-light Killer Maxi. That's equivalent between an 800 and a 1.2K, depending on what manufacturer of an HMI fixture that you're going to compare it to. But again, only drawing 540 watts. So you can actually, you go into a house, you plug in 1.2K into a house, and you're pretty much done. With this, you can, plug in 20, 30, 40, 50 of them in a house and not have a problem. That's also modular. You can make a 4-light Maxi out of it with an accessory frame that all these can be used in any orientation you can think of. So you can actually hang our 4-light, put a traditional 6K space light bag on it. Depending on your ceiling height and the lenses you choose, you replace many, many, many 6K space lights with just one fixture. And our last one is the drone Source 4 LECO retrofit kit. So you take your own Source 4 LECO, takes about 10 minutes, and you can transfer it and into becoming a plasma LECO. So like you would have a Joe LECO or any kind of HMI that you would have to convert it, you can convert it in about 10 minutes. No heat coming out of it. I mean, literally you're not burning up gels, not burning up hands. And it's just pretty amazing technology what's been created. It took us about 2.5 years to get to where we're at now, and we're really excited. Thank you for having us here. And if you have any questions, I'll be out there.
How much are those lights?
All the prices are right on your price sheet that
There
we
you go.
handed out. So, and they're on our website for those watching at home.
We're very fortunate to have AbelCine be one of our dealers, Chicago, Burbank, and in New York.
What's the wattage of the drone?
The drone is 270. Every single source is 270 total system watts.
So you have the same engine in all 4 of their fixtures.
Correct. The Killer Plasma Maxi, it's got 2 of them in it, so it's 540 watts. Correct. Yes, sir. There is no ballast. If what you would be considered a ballast would be our power supply that allows you to run AC, because it's a 28-volt DC system. So this, yeah, you can put this on the floor and run an extension cord. It's not a problem. This is where you would unplug. Whoop, excuse me. You would unplug it right here, and you would plug in your 18 to 38-volt DC batteries. Anything you can plug in here, 3-pin XLR will run it. What this is what we call an RF driver. So that little bulb I showed you, it's electrodeless. There's no electrodes inside. That's the reason why we get a 10,000-hour bulb life, is there's no wires to it. It's all done with radio frequencies. So this is a radio frequency driver in here. A ton of radio frequencies get blasted into the back of the bulb that create an explosion and turn it into a plasma state. So at that point, this has to be attached.
It's basically a little microwave oven.
Yeah, exactly. And before anybody asks, no, there's less radio frequencies that come out of our lights than the cell phone in your pocket. We've already gone through FCE, FAA, everything. We're even approved to go on an airplane and shoot on an airplane 10,000 feet in an airplane.
So any more questions for Jamie? He'll be out with the Hive display, showing you all the different fixtures. And thank you very much.
Thank you. Appreciate it.
Thanks. Our next presenter, our next company, is Light Panels. Light Panels is sort of, well, I guess you would call them the grandfather of LED lighting for the motion picture industry. They have the largest lineup of fixtures, certainly, as well as probably the sort of the Mr. Coffee, if you will, of LED lighting. It's what you associate an LED light, at least for certainly the last few years, for the motion picture industry was a light panel, whether it was the original brick or into their 1 foot by 1 foot fixtures of different types. Well, now Light Panels has many other fixtures in addition. Why don't you plug in right over here? That way you won't have to run your lines too long. Now they have numerous different fixtures, and they're going to show a few of them to you now. Fred, here you go.
Well, good afternoon. Thank you for coming. I'm Fred Horn. I'm probably not well known in the industry. I'm kind of new to it. It's a joke because I've been around rather a long time. You've probably all kicked me around. You either kick me off set. Or I'm getting to be that old guy, you know. So anyway, light panels. Light panels is we've set the bar in the industry. We've been around a long time. A lot of you know of us from our smaller lights that go on top of the cameras, and the Mini Pro, and that started a whole camera revolution that kind of ended up coming to this, and this is our Luma, and one of the latest entries to our whole line, and it can be run by AA batteries that you can find on any street corner, and will last an hour and a half, 2 hours on those. It also can be used on your power tap. So the power tap can go right in there. And the reason why we call this the Luma is because it has more lumens than our other one, which is called the Chroma, because of the amount of the LED bulbs that are in there. Now, the whole line, from top to bottom, we have made originally into high speed. So we can go, any one of our products here can go to 1,200,000 frames per second at any shutter angle. And that's an amazing thing to say. And I don't know if they did it on purpose. It has all to do with our dimming system that Mitch kind of started to explain. I can explain a little more if you come over. But it's a DC. We use a DC dimming system, direct current, so there's no flicker. And kind of fun. So you can show them the Chroma. There we go. And this is the Chroma. This is the one that does 32 and 56. Also, you can plug it into your camera top, and also we'll take the there we go. We'll take the AA's. So you have a couple of different routes to go, but if you take the AA's out of it and you use it on top of your camera, it really lightens the load. It's a very physically light piece of equipment, and part of the problem with some of the earlier pieces of equipment, they were heavier. They were made out of cast iron, so they wore like they were cast iron, and worked quite well. But we've learned a lot from that, and we've developed something called the E&G. This is a very small 200-watt daylight light, and it works quite well on top of a camera. But as LEDs go, and this, as long as you're not using any kind of microphone that's shotgun microphone that's on top of the camera, this will work quite well. It puts out about 200 watts of light, has a pull of right around, pulls the same wattage as a 30-watt bulb. So this can be used, this is a back plate, and so we'll set that up, and that's just sucking in all the light. So it spot floods, and has a lot of accessories, nice two-door barn door on it, and has a gel frame that goes in the front of it. And this is something that's less than $700. So it's a very popular piece. We've made it into a flight kit that has three of these lights in it, and along with a softbox and stands and gels and everything else, and that's less than $3,000. But we're finding that's a very popular kit. Now, we also have the 1x1s that I think everybody in the room knows. This is our signature product, and we made this with a battery back also. So it's a good walk and talk light. You'll see these used in a lot of news programs, CNBC and a lot of the other ones, and so that goes right along with. You can get it in V-mount or you can get it in gold mount, and it cranks out a lot of light, and it's bicolor and can be used as any kind of walk-along light or outside lighting, or even if you're shooting in dark places at night and you don't want cords and stuff like that. I've heard of a lot of people using that. Now there's gels and frames, egg crates that can go on the front of that. So there's a lot going on with that product. Chimera makes a really nice lighting tent for that goes on that, has different grids and different pieces. These are our Fresnels. All our Fresnels can be used on battery power. This pulls 1 amp, this pulls a half an amp. So this is equal to like a 600 watt light. I just don't want to really do that. And So, but this is running off this battery here. So this makes it a lot more efficient, and it's a very cuttable light, controllable light. One of the things that Mitch likes to talk about is LEDs that can be controlled and that are consistent as far as the color temperature. And this is 5600 Kelvin. It's our solar line, and weighs less than 9 pounds, and is very transportable. Dimming and focus are DMXable, so you have two sliders on your dimming board, so you don't have to crawl up there and do a little more spotting or flooding. You can control that, and that's one of the features that both these units have, and the lighting, the LDs really appreciate, the board ops really appreciate, because then they don't have to send anybody up on a ladder to spot flood it. So that works very well.
Tungsten version too.
Yeah, we have Sola, which is daylight, and Inca for incandescent. So you have 3400 Kelvin. I have them both here. So if you want to stop by where we are, you can see both versions. This one is equal to around a 300. So this is again a Sola, so that's putting out daylight, and controllable. So it has a very nice shadow, very hard, and again can be controlled with your barn doors. Everything here comes when you buy the units. They come with the barn doors. This is an 8-way barn door, and this is a 4-way barn door. So I think people who do a lot of creativity here appreciate the 8-way barn doors when they get up there. We do run this on battery, as I said this earlier. Both of them can be. We've developed this product that will. Here, Bob. There we go. Hang on to that for a second. This product, we have, it goes on the bottom of a stand, so you can put the battery elsewhere other than having it on, if you're sticking it on a car rig or something like that. It works out quite well. We also have a battery back for something we call the Hilo. The Hilo we have at our booth, and that's a 1,000-watt multi-bulb unit. And that can be put on 2 batteries that are hot swappable. So that's equal to a 1,000-watt Fresnel. And where it's being used a lot right now is interviews on sidelines of baseball, football, all the sports agendas. You can take one battery off. It's hot swappable, meaning the light doesn't go off. You take a battery off, put a new charged battery on. You still have, it's a dual battery situation. Anyway, Mitch is kind of inking in on me, so if you have any questions, please stop by our booth here, and we appreciate any kind of feedback that you have. And here you go. Thank you.
Thank you, Fred. So that's light panels. Lots of different fixtures available. It's not your grandfather's light panel anymore. We have next up is Lowell. Lowell, as local a manufacturer as you're just about to get, their offices, I believe, are in the Brooklyn Navy Yards. At least that's where they started, and they are manufacturing a new line of LED lights. They classically had started with tungsten light fixtures and are known throughout the industry as everybody's starter kit. I had a bunch of them. Everyone starts with Lowell lights because they're simple, basic lights that are very efficient, and you can just use them to get going. And the first kits were tiny, tiny little lights. Actually, the very first Lowell product was basically a plate with a little light bulb mount onto it, and you can kind of just clip it anywhere and stick it and do whatever you needed to. Now they have a vastly larger array of tools, and they have moved into the LED light world. So without further ado, low lighting.
Thank
Eric.
you very much. Good morning, good afternoon, everybody. Thanks for coming out today. Thanks to Mitch and everybody at Able for inviting us. My name's Eric Drucker. I'm the Eastern Regional Manager for Tiffin. I couldn't hear all of that, actually. Did he say we're in Brooklyn or out in Long Island?
Yeah.
Brooklyn. Yeah, we moved. We moved. We were in Brooklyn for a very long time. About 4 years ago, almost to the day, we were acquired by the Tiffin Company. And we now join the other group of family of companies that Tiffin has, which of course is Tiffin Filters, Tiffin DFX Software. We have Steadicam. We have Listag teleprompters, low light, Domke bags, Davison Sanford tripods, everything you can get right here at Able. One thing that Mitch did say that was absolutely correct is that we're everybody's first light because there's always certain concepts and principles that we've tried to build into everything that Lowell manufactures. And just by a show of hands, has anybody not used a Total Light? Has anybody not used an Omni Light? No, nobody. Okay, so, well, what is the core of Lowell Light? Lowell Light for traditional location fixtures have always been lightweight, really rugged, stuff that's easy to repair, things that will last forever, represent a really good value for what you buy. I tell people all the time, you know, you're gonna buy lights once, you're gonna have them forever if you buy them from us. You're gonna want a new computer, you're gonna want a new camera once every 2 years, but your lights are a great investment because they're gonna last forever. We've tried to keep that going with all of our new equipment as well. So we've taken a very, I don't want to use the word simplistic or simple, but that kind of applies to the approach that we've used. But it is a sort of very simple approach to a couple of situations for what we've made for lights, which is a holdover from the earlier concepts, which have always worked out well. This is called a Lowell Blender. And this is our very first LED fixture. And this is a kit light. Everybody looks at it and says, you know, it's just about the same size as something I could put onto a camera. Is it a camera light? It's like, you can put it on camera, but it was initially designed to go onto a stand. And one thing that we've just done recently is we've repackaged these. We can now get 3 of these in one kit. So the blender, again, back to, for lack of a better word, simplicity, has 2 sets of LEDs, and we've got 2 sets of knobs on the back, which correspond to the 2 different colors. And it works better when you turn it on. There we go. Okay. Top knob gives us tungsten. Yeah, try again, lighting guy. Top knob gives us daylight. Bottom knob gives us tungsten. The tungsten that it puts out is actually a little bit warmer than photographic tungsten at 3,200 degrees. It's about 2,800. Why? Household practical lamps, mostly about 2,800 degrees. Top side, a little bit cooler than photographic daylight. It's about 6,000 degrees. In case it's cooler outside, it gives you more latitude to mix colors. What it lets us do is it lets us mix, though, between those two. It lets us blend, the name blender, the 2 different colors together. So in an environment like this, we've got some tungsten up there. We might have some tungsten or something else that's bouncing around. We've got whatever color temperature these are. All I know is if I pick something that's white, looking at it right now, it's way too cold. If I go with the other side, it's probably a little bit too warm for the room. But by mixing the 2 of them together back and forth, we can get it to a point where we say, you know, maybe right about there, it's looking pretty neutral. If we had daylight coming in through a window, we had a true mixed lighting environment, which we could simulate more outside because we've got a lot of daylight, you could really see the effect much better. But again, the idea is if you're shooting somebody up against a window, and you've got a lot of ambient daylight coming in, you could match to it. You could follow them, go someplace else, and then work with whatever sort of ambient light you have inside of a room. All metal, really big heat sinks, because as Mitch was saying before, while we think of LEDs as not getting too hot, internally they get very hot. And they'll get hot enough to cook themselves if you don't dissipate that heat. So we've got these very big heat sinks all on the outside. It is a DC light that comes with an AC adapter. The AC adapter you could plug in anywhere in the world. It even comes with 2 sets of cables so that you could plug it in if you're going to Europe or some other countries that use 2-prong adapters. But it will work with anything from 12 volts up to 15-volt batteries. So everything from an Anton Bauer brick down to little, you know, camcorder-sized batteries, which we make things called battery sleds. So the battery sleds will take, you know, Sony L-series, Panasonic, Canon, so you could just clip it in there. If you wanted to have somebody walk with it, they could clip the sled to their belt and then walk with it. Or again, we could replace this and put it on top of a camera. And we have short pigtails for Anton Bauer, you know, D-taps, 5-pin cigarette lighter adapters, on and on. And again, we now have that in a 3-light kit, which is very attractively priced. I don't know if we want to talk about pricing just yet, so it's very attractively priced. Also, each light comes with 3 different pieces of diffusion, which will slide into the front, so you can just broaden up the beam a little bit and soften it just to knock off the edges. The next thing that we came up with was this series. Let's get this up a little higher so everybody can see it, which is called, oops, thank you, our LED Prime series. And this is our first foray into larger LED fixtures. Lowell's had a tremendous amount of success with what we have always had as a line of studio fluorescent fixtures. So our first stab at these was to sort of mimic what we had before, basically so that everybody was comfortable with using studio fluorescents, has something which is very similar, that the form and the function is very much the same. And to follow that also, what we came up with first was a tungsten balance fixture, because we thought that that's where most places were going to be going initially. There we go. Okay. This is the tungsten balance version. We do have a daylight balance version, and back at our table you can see that we have 2 different sizes. You can get both color temperatures in both different sizes. Starting from the outside, we're talking about something which is all metal, really robust, so that it's going to take a real beating. We've got, you can see there and here, large slots for convection cooling, large banks of heat sinks on the inside, so this will never make any noise. There are no fans. You don't have to worry about gunk getting in there, eventually fan blades coming unbalanced or bearings getting gunked up, so that it will always be completely silent. Dimmers, of course, are built into the heads, and there's a number of other things that we could do on the inside through the software. It's going through 255 steps, so if you have it on a console, you know, of course, you're going to see very, very smooth transitions as it's going up and down. As we turn it around, hopefully everybody can see this, and I don't know what this is going to read like on camera, but we've got it dimmed down so maybe you could see better. We look to get as much output out of this as we possibly could, given the size. Okay, so if you have a bicolor fixture which is using 2 sets of LEDs, obviously you can have them up full and then get the maximum amount of output out of it. Where as soon as you start to dim one set down, what happens? You're going to lose roughly 50% of your output. So we came up with something thinking that, okay, mostly we're going to be going into studios with it. Let's go with as many tungsten balanced LEDs as we can get in here. And you can see that the bulk of these are tungsten balanced, but there are a couple of daylight balanced ones which are thrown in there as well. Not a bicolor fixture. We can't go from daylight to tungsten back and forth. What we can do is we can calibrate the color around tungsten. So when you get this and it comes out of the box, it should be about 3,200 degrees because everything's preset at the factory. We can go in through the software. We could split the 2 different colors of LEDs into 2 different dimmer channels. And by dimming the 2 of them independently of each other, again, we can calibrate that color temperature up or below 3,200 by about 200 degrees. Effectively, what we're going to do in this case is we're just going to dim down the blues a little bit. So by doing that, we could bring the fixture down to about 3,000 degrees, which will be effective in a couple different ways. The first thing is if you're running everything up full, we find that most Fresnels are running a little bit warm anyway. Excuse me. So again, we could drop this down to about 3,000 degrees. If you have things dimmed down a little bit, you might help to compensate for it a little bit too, because everybody now has 2Ks and baby 2Ks that they used to use up full a long time ago. You lamp them down, and everybody's still running their dimmers down at probably between anywhere from 40 to 60% to cut down on power and try and make the lamps last a little bit longer. So this will help you balance things out a little bit. What you probably can't see from back there too is that we've got screws here and here, and there's sort of a seam that runs this way. This is actually a combination of about 10 different panels of LEDs. Each one of those is not sort of hardwired in there. So if you do lose one faster than its 50,000 hour life, we could just pop out a panel. There's a quick release connector on the other side. So you could do a field repair with one of these with just a Phillips head screwdriver. I think I just got the high sign. Okay, thanks very much. If anybody has any questions, we'll be right outside, and look forward to seeing you. Thanks.
Thank you. That is Lowell. Again, everybody's starting light. And Lowell not only is very rugged, straightforward lights, if you will, but also very attractively priced fixtures. And I would say that this line continues that attractiveness. Someone asked a question here and also had just asked me some questions about pricing. Everyone here has all the prices, just our regular listing prices for all of these fixtures, and as well, all of these lights are on our website. So for those watching via live stream, just to let everyone in the room know, as well as our live stream people, we are, of course, I blabbered on a little too long, so we are running a little bit late with this section of the seminar. We'll try and make that up as we go along through the day. I'm going to turn this now over to Nyla and let them have their say showing their products. Jim, here you go.
Thank you, Mitch. So I'm Jim Sanfilippo with Neela. We manufacture Yes, yes. Oh, there we go. Great. All right, I'll start this over again. I'm Jim Sanfilippo. I'm the president of Neela. We manufacture high brightness LED fixtures. We've been shipping product now for 5 years. We started with a smaller unit than this one called the NH. Also have the J and H, which stacks together. And what we really do is replace HMIs. So our little fixture is a 200 watt HMI replacement. This is a replacement for a 400 watt HMI, and it draws 75 watts. We just introduced this at IBC in September. The big new feature for us is both AC and DC input. So the AC input on all of our fixtures is 90 to 250 volts, and the DC input on this one is between 10 and 18 volts. On the front side, I don't want to blind everybody, you've got the lenses. We're using our holographic lenses. So without the lens, it's a very narrow beam. It's about 8 degrees. So the different beam angles are 10, 25, 40, 60, 80, and I'm going to show you, this is a 10 by 60 degree lens. So you can see how it spreads it out side to side. The holographic lens does a couple things for us. It's extremely efficient. Holographic lenses, the widest holographic lens only eats up about 15% of the light. The narrowest one is only about 5%. So 85 to 95% transmissive, we're not trapping the light in. A traditional Fresnel fixture will trap about 60 percent of the light or more, depending on the design. So we're really about efficiency and giving you a long throw of a fixture. Everything we do is one color temperature, either daylight at 6,000 Kelvin or tungsten at 3,400. We do make a rigid color correction, so you can just drop it in and change your color just like you would with a traditional fixture. On the back end, we've got control for dimming, 0 to 100%, either at the fixture or through DMX. We've got a lot of installations that are using these fixtures. French Television has over 25 studios that they've had online. Their first studio was in Tahiti. They did the installation and they thought the energy savings is going to be great, the maintenance savings even better. They calculated originally it'd be about 1.5 years on the return on their investment. It was 7 months because the cost of their power there is so much higher. Most of the studios that they've done in Paris, where their cost of power is a little cheaper than what we pay here, their ROI is around 18 months for these types of installations. We've done a lot of work for the federal government. The next size up from here, the Boxer unit, which is twice as bright as the Varsa, we originally designed it for the U.S. House of Representatives. In the main chamber of the House, we've got 24 fixtures. So we went from an installation of 24,000 watts to less than 6,000 watts, gave them 5% more light, and gave them total control over the dimming of it through a network. In that network, they have control in different buildings, so they can turn the lights on or off where they have control of their remote cameras. So that installation, we're happy to say, paid for itself in 18 months. And so we're now saving the federal government and all of us, tax money. So this is the basic line. The Varsa is, like I said, we just introduced it. We'll be shipping the first units end of next week, and the prices are on the sheet. We think it's very competitively priced for a unit that can take both AC and DC input and replace a 400 watt HMI. Durability-wise, CNN has been using our lights in the field now for almost 4 years. They haven't sent any back for any kind of repair from damage. And we all know how TSA can treat equipment. It'll last. There's a video online of me taking the original fixture and banging it on a table like I'm trying to pound a nail. All of our fixtures are that durable. You know, the ones that went into rental inventory in 2008, they're still in rental inventory. So they get treated very harshly. As you all know, rental equipment, 18 hours into a day, that's the last thing you want to do is slowly pack something up gingerly and put it away. You throw it in the truck because you got to get out of there. So durability is, you know, paramount for us. Long throw, high brightness, and then giving you the dimming control and control with the holographic lenses is pretty much all you need for everything. On the Varsa and the Boxer, we have the Chimera brackets built in so that you can just throw on a soft bag, you know, go from the outside interview to the inside interview, soften it up really quickly. And this has been on all day, and you can come feel the heat on this. It's nice and cool. So I think to help you on your time frame.
You want to just mention flicker?
Oh, right. Mitch's favorite thing, because they're so, you know, phantom cameras are so famous for AbelCine. Everything we do now is flicker free through the full dim range up to 1,500 frames a second. So if you're down at 5%, no flicker. When you're at 100%, you're flicker free at any frame rate. And we've tested up to 100,000 frames a second. And just solid. It's DC to the source, right? So when you're at 100%, there is no modulation, there's nothing to flicker. So we could do infinite frame rates, but most of us aren't going to get past 100,000 frames a second. So, but through the dim range was one of the new things that through our AbelCine's help, you know, in prompting, we were able to create some software that allowed that full dim range without any flicker. And we've tested it thoroughly with the Boxer. We need to do the test with the Varsa to verify it. It probably will realistically be around 3,000 frames a second, but we want to test it and make sure that that's going to be the case. So, did I miss anything?
I think you got it covered. There's also the SL light, which is out at your booth.
Yeah, there's 4 sizes that we make. The NH and JNH are the same size, 200 watt HMI replacement. The Varsa is a 400 watt HMI replacement. The Boxer is an 800 watt HMI replacement. And then the SL is a 2.5K HMI replacement. And the great thing about that is it only draws 500 watts of power. You can get 5 of them on a 20 amp circuit, where you can't even turn on an HMI, a 2500 watt HMI without a 60 amp service. So it's really efficient. If you're, you know, high-rise building and you can't pull power, you can't bring a generator, or you don't have the money for the permit for the generator, all of those things, plug into house power, you've got, you know, full-size HMI replacement in LED.
Thank you.
Thanks.
Thank you, Jim. Good job. So we're going to move on to our next manufacturer as we're clicking along. This is PRG with the True Color line of remote phosphor lights, and they're making their way in as we dance back and forth a little bit with our different manufacturers. This is sort of a new style of lighting fixture. Again, they have 2 different models, but this is where you have the emitter source, and physically separated from that emitter source is the phosphorescent panel, which will be providing additional where really the illumination occurs. So just while they're setting up, Trisha's provided me with a thumb drive of one little graphic she wishes to show. So I'm going to switch out of the presentation, and I'm going to load that up while she does her presentation, which is there. It's up. It's plugging in. It's happening any moment. You ready?
Yeah.
Here's your mic, and I will get this up ready.
Hi, I'm Trisha Moss with PRG. Brand is True Color. There's a product out called the HS Light. You may have heard of it. It's a remote phosphor luminaire. I'm based out of the West Coast in the Los Angeles area, but I do cover pretty much North America. So here in New York, I'm always able to get a hold of. I was asking Mitch to throw up my spec sheet. I just thought it would be a good tool just to look at some of those integral parts of like what power it takes, different color temperatures, and also a quick review of some of the color quality that he was discussing earlier, CRI, spectral distribution curves, adherence to black body radiators, green magenta shifts, things like that. I'm gonna roll this guy over here actually. So remote phosphor lighting, it's an LED source, but it is a different interpretation of it. Some people call it LED 2.0 or a deconstructed LED. That's another way to look at it. The primary things that drive LED technology, you have a blue pump. That's what starts it all off. That blue pump hits a phosphor coating, which is in the diode. That phosphor coating is what holds the color quality, what makes it a very good 5600, what makes it a very poor 3200, etc. Depending on how that chemical balance is put together, that's what's going to give you a really good light, a really light, or the right color temperature that you want. So what we do is we address each of those pieces separately. Before I turn this on, here, let's pop this out. So these panels right here, these are our phosphor coatings. These LEDs in the back, these are our blue pumps. When I do turn this on, I'll turn it around, you can see that it's actually just like 425 nanometer proper blue light. And then the coats on this are the chemicals, which is going to give you your color quality. Slide this guy in. So, here we go. What's unique about this light, as opposed to some of the other LEDs, is that you're not dealing with 100 or so different point sources with multiple shadows that are all competing at you and crossing paths and giving you that, I call it a waffle. Sometimes when you have different color temperatures, you can see it as a rainbow. It's really hard things to get around, especially if you're close to a source like this. These panels are taking off in a Lambertian element of lighting. What that means is it's a flat and even surface. This phosphor in this corner doesn't know it's in a corner. The one in the middle doesn't know it's in a middle. And it doesn't know that it's facing you or facing Mitch or facing me. It's just going off in a good 360-degree soft approach. So I'm going to turn this sideways and actually turn it on. We can get quite a bit of light. Sorry, I'm trying not to hit you guys too much. But I'll use myself. So you can see that the shadows are really soft, which is nice. It wraps really kind of cool, comes around the corner. And again, it's because you're getting that, not a hard source. It's not a hard source tool. It's a soft light. I think mostly in the market right now, people are looking at it as replacements for 2Ks. I see it at studios. In the motion picture world, a lot of people are replacing it where image 80s are showing up, which I think is really interesting because it's a fifth the size, which helps. Can you turn the monitor back on? I wanted to show you guys that. Can you go to the second page? Or that's you. Yeah, here. So earlier, Mitch was talking a lot about light quality. And the reason that we call this brand True Color is because we adhere to the color quality. That's our primary directive in doing this. It's not just making a light that's bright and shows up, but it's actually giving you a tool that you can use that's going to interface really well with HMIs. It's going to work well with tungsten, that is going to color correct properly in your cameras. It's something that, it's not going to give you a green side over here and a magenta side over here. So he talked a lot about CRI. This is an ocular system. These values that show up, they're based on eye interpretation, not on camera interpretation. So you always have to be really sensitive about that. Cameras read things different than our eyes do. But being that this is probably the most commonly referenced index, we do look at it. We break it down into these R values. I remember somebody asked before what those slots were, and you said there was some 12, 15 different slices. most people look at CRIs up into here. These are the complex pastels, and these are the saturateds. With different color temperatures of different panels that we have, we do evaluate it. As Mitch said, it goes up to 100 on a scale, 100 being perfect. Nothing's really ever perfect. But we use a pretty fancy spectral radiometer. It's a scientist tool to get these numbers. And then that'll give you where your average CRIs are. So that's what that means. This information is all available on our website. It's on our specification sheets. I can give that out to you, no problem at all. These guys, this is the visible light spectrum, 400 nanometers up to, usually cameras cap somewhere around 650 or so, but we go on a little bit further. These are like thumbprints. What proper tungsten looks like tungsten 32. If you're looking at like a tungsten element, it would kind of go like that. This dip is one of those like hard parts for LEDs. It's the Stokes shift. For every opposite equal reaction, you get a little divot. But these are good ways to look at color quality of light. And then black body curves, which he spoke to as well. The presence of green or the absence of green being your magenta. You see that as the up and the low here. And 27, 32, 43, 56, these are how we fall in the black body radiator. Again, it's not perfect. It's very hard to be perfect in this world, but we are pretty close. We are pretty close to that. And this remote phosphor technology is something that we see as being a developing and a growing tool for you all to use. Something that addresses a lot of problems, multiple shadows, the brightness factor, the proper color quality things. Right now, the HS is the second unit that we have out in the product line, but there's going to be more. So it's a relatively new technology on the market, but definitely keep your eye out for us. And if you guys have any questions, please.
You might want to mention the different color panels that you have available.
Oh, yeah. The 20, it's said here, 27, 32, 43, and 56. These are all the different panels that we have out. Here. Do you guys want me to do any changes of the light quality? Is that of interest? Or, I mean, of course, afterwards we can do that out on the floor, but does anybody want to see a specific color? 27s, 43s? Which one? 27. 27? Okay. Can you hold this for me?
Certainly. So it's really, she's just going to swap out the these acrylic panels that go on the front of the unit, and that's where the phosphorescent materials are painted onto that surface. Your question? This is the HS. The photon is this small little fixture down here. The HS uses about 400 watts, and it's equivalent. It has about, if you compared it to a 2K zip light, soft light, it has twice the output of that 2,000 watt light. So you.
Is dependent on
here you go.
A lot of that's dependent on your distance. LEDs, they fall off a little faster than traditional tungsten does. So if you're in a 10-foot range, it's going to be closer to a 4K. If you're like at a 12-foot range to an 18-foot range, it's going to be closer to a 2K. So yeah, always be careful with LEDs in your fall-off range. Your distances don't correlate the same as traditional tungsten. They never will.
Yeah, the way you're emitting light is different physical. It's not necessarily bouncing light, or it's not transmitting through a lens. It sends light differently. So you will find, given a distance, it will drop off differently.
I don't ever recommend doing this with a microphone in your hand. It takes a few extra minutes. Testing our skills today. Thanks. Mind your eyes, it's going to turn on when you do that.
So there's a safety cutoff switch which is why, because you don't want the blue LEDs blasting you in the eyes with that off, because that could actually like give you an eye sunburn. So there's a safety cutoff switch, which is why when those panels go on, that it popped back on. There's a regular switch on the thing. 27, 32. We accidentally just put two 32s back in there. But you can see that small change, which is actually, this kind of works out to our benefit right now. So it kind of warms up a little. Yeah?
How durable are those panels? Can they be scratched?
They're pretty durable. There's one actually heading back to you right now. So there's two sides of it. The glossy side is just plastic, so have fun with that. I usually recommend keeping it on the outside because we know why. We know why. The inside is where it's baked on. I mean, I can scratch on it it's fine. But I wouldn't recommend, you know, dropping it on the ground and doing a dance on it or anything like that. But they're pretty durable. They're flexible, oh my goodness. Anything else?
So Trisha will be out at her booth, the PRG True Color booth, and thank you for presenting. I'm going to move on to our final manufacturer of the day. So we'll get our presentation back up here. If I go to, I can't find my mouse because I don't have that screen up. There we go. Okay, and we'll go back to our presentation. It's smooth as glass as Xylite makes their way into the room with their light fixtures. And we're going to take a look at that, and after that, then we'll adjust our schedule accordingly for the day so that everyone has a chance, and certainly we all want to hear from David Mullen, who's going to do the next presentation.
Thank you. How's everybody doing? Everybody learn a lot about LEDs today? My name is Jeff Hamill. I'm from Xylite. One of the differences of our company that sort of sets us apart, aside from our products, is that all the key team members of Xylite have industry experience. When I say that, what I mean by that is image capturing, building quality items into a small form factor, and myself, I still work in Boston as a gaffer. Been doing it for 25 years. So early on, back in 2004, I was asked by Xylite if I would join the team, and once I saw their products, I couldn't say no. So we have basically color mixing that's a little different from what everybody else does. Not only is it in a small form factor, but on the back of this light, as with all our lights, we basically have a lighting console built in. I'll pass this around. Be nice to get it back. Go to the next one. Am I controlling it? Okay, I'm in control. Very in control. All right, so right here, this is sort of what we call the Xylite edge. We use red, green, blue, and in some cases amber to get our color temperatures. So that allows us to adjust the color temperatures to match any situation you may be in. Full color output, and then the cool thing that allows us, that the color primary mixing allows us to do, is add plus or minus green. So whatever lighting condition you find yourself in, you can adjust that in. So if you're shooting on a fluorescence or whatever, you can add that in. Wireless networking is built into every fixture. So each light can talk to each light, or you can use the wireless remote. And I can touch on that a little bit later on in the slides. There's only 5 slides, so I'm not going to bore you guys to death. They're all made in the USA, out in Oregon. So that also sets us apart from a lot of the other LED companies. Spacebar. Mac versus PC. So here are our 3 basic instruments right now. I'm passing around the Z90. You'll be able to see it in a minute. That was one of our first color mixing products. Well, we started with color mixing products. That was one of our first. Then the IS3 is sort of the bigger version of that, more of a panel light. It just puts out a bigger spread of light. But it has all the same features, 10 channels of addressable wireless built in, so the Z90 can talk to the IS3 or vice versa, or you can use the remote. Our newest product is the F8. It comes in white only, so you got to get it in either tungsten or daylight. It is IP54 rated, so it can be out in the weather. The next slide will show a few in-field applications of the, that's me again, I keep forgetting. All right, so here it is out in the desert with Anderson Cooper at CNN. Harsh environment, dry, dusty, potential overheat situation, but it works fine. It's been in many deserts and rainforests. Here, for a set of a Halloween shot, the IS3 is used in the background to paint with light in the background, to just engulf that. Don't try that with any LED light. Here, just this week, I don't know who's familiar with Tom Guillemette, but he was up on Mount Washington trying to shoot the formation of rime ice, which is freezing fog. And Mount Washington has been trying to get this accomplished for many years, and Tom was the first one to do it. Now, big part of it was the F8. This is out in, overnight. It's at 20%, dimmed down to 20%, minus 20 degrees Fahrenheit. In the morning, it's still on, and Tom successfully got his time lapse of the rime ice formation. You can see it even forming on the light. So here's a good testament to some of the advantage of LED lights, that they don't put a lot of heat output right there. I mean, and it's still on. So I'd like to say, we played a small part in Tom's success. So getting back to, the setting us apart type thing is our Xilinx wireless. It's really a networking. I mean, there's some wireless out there that you can, from a remote or some kind of console, you can control it wirelessly. But each fixture, in our case, can talk to another fixture. So you don't need the remote. And it's built into all of our instruments. And it is on a Bluetooth Zigbee type frequency, but it's our own proprietary, say that fast. Only because, people say, well, what do you make for the iPhone or the iPad? But then if someone's walking by, they'd be able to change your lighting setup. So we have our own frequency. Again, it's built in, it's 66 feet. And again, we didn't want to extend that too far, because if you're in a situation where there's different rooms set up, like media day, you don't want your lights changing. The remote on the back has DMX. So not only can you control it from the fixture, the remote, you can also plug it into your lighting console and control your lights from there. You don't have to run the DMX cable out to each fixture. And then, we're right outside here, right outside the door. If you guys have any questions, I'd be happy to answer them, or you can come on by the table and play with the products. If you want more information, if you're not sticking around, to go to our website, it's all on there. Any questions? You guys are bored to death.
No, right. I think they're going to save them all up for your booth.
Yeah, please come on out.
Especially to come and check out the other fixtures. I'll take a quick question right over there.
Oh.
So the F8, what's the watt per amp? What's the watt?
It's 90 watts, and we've tested it, and it's the equivalent of our 125 pocket par. And it also can run on battery. There, it was actually running off a marine battery with an inverter, so it wasn't a battery on the back because it just wouldn't work. But run it off either a V mount or Anton Bauer mount battery. Yes.
I was wondering about the RGB mixing. Are there any issues with color vision or mixing?
You mean in mixing the
Just to repeat the
colors?
question for live streamers, you're asking that in doing by pulling separate LEDs that have R, G, and B color values, and also an amber, are there any issues with color rendition?
Well, our products are one of the few that have a microprocessor built in. So when things change, whether you're changing the dimming, which changes the power, or when the LEDs, all the LEDs do age, it takes a long time. But the processor will compensate for all that. That's all programmed in. And also, our lights can be recalibrated at any time. Send it back, we just reflash it. So they're not, they're one of the few that's programmed and calibrated for accuracy.
I would also just note that, mixing red, green, and blue in order to get full color spectrum goes back. I mean, that's what all your modern cameras do. That's what all your projection sources do. That's what Technicolor did. It's nothing new. That's how you create the full spectrum of light.
Any other questions? Did I answer that sufficiently, or?
Yeah, no, I guess just because I've heard that there could be issues with the green band making a very narrow spectrum, you may be missing parts of the curve.
The question is it missing parts of, are any of the emitters missing parts of their color spectrum?
No, I mean, it's not full spectrum. It's just RGB and RGBA, but no, they're all equal and full. So you can, of course, you adjust that as you adjust your color temperature. You're going to get different variations.
Thank you so much.
Thank you.
So that is the end of this particular seminar. We are running a little bit more than half an hour behind. So normally this is going to be when David Mullen was going to start his presentation, but we're going to just shift everything by half an hour. So if you want to, everyone go check out all the lovely booths from our manufacturers with equipment, and we're going to start up just a little delayed for the next presentation.